the most cheesiest you've ever seen. Example 1. All right. Scott, he's got his eye level is 1.5 meters above the ground. Where do you think I could put that 1.5 meters? His eye level, 1.5 meters above the ground. Oh boy. His eye level, 1.5 meters above the ground. I won't call it its height because he's still got a little bit of forehead, maybe a 5 head, depending how big it is. All right, above him. Anybody ever heard of that term before? You got a big forehead, it's a 5 head? No? All right, never mind. Got 4 and 5, yeah. Yeah. Okay, ready to go? 1.5 meters above the ground, stands 30 meters from the tree. Ready? Angle of elevation to the top of the tree, to the bird. Angle of elevation. Remember Zach standing here, all right, looking up at the clock. How was that angle of elevation formed? With the horizontal and him looking up to whatever object he's looking up at. So here is my 36 degrees, angle of elevation, with his horizontal sight up to the object. And what are we looking for? How far above the ground is the bird? So how far above the ground is that bird? Do you see a right triangle I could form? Yep. But can you get me I don't have a side though. I don't have a side in that. I have 36 degrees and that's it. Any other side length up there I could put in, Andrew? Which is 30. He's still the same distance away here. Yep, 30 meters. Now, can I find x in one ratio? No. What am I going to have to find first? I'm going to have to find the other leg, right? And then what can I do with that length to find the entire length the bird is from the ground? Add it to his eye level, 1.5. All right, so how can I find that leg then? This side is my opposite, and this side is my adjacent. So I'm going to end up using tangent of 36 equals y over 30. When you find y, is that my final answer? No. Why am I asking? Because I don't want you to round it yet. So y is going to be equal to 30 times the tangent of 36. And I'm getting out 21.79627,584. And I still need to add that 1.5, and you guys have rounding directions on your paper, correct? Nearest tenth. So nearest tenth, what are we looking for? 23.3 meters. Yes?
I have a question about like tangent and cosine. What do they mean? Like, what is it? Like, what is it?
Are you asking how your calculator gets a value for tangent of 36?
Like, what is it?
Comes up every year, so I'm prepared here. So how does your calculator get that the cosine of 30 is 0.86666? Okay. Let me show you. That's a graph of the cosine curve. Okay, sine has its own curve, tangent has its own curve. All right, that is a graph of the cosine curve. And you guys will learn this next year, but when you graph sine, cosine, tangent, you actually graph in degree measures. Okay, you don't go by 1, 2, 3, 4 like you usually do on the x-axis. It's in degree measures. So if you went to 30 degrees, all right, if you found where 30 degrees was on the x-axis, guess what the corresponding y value would be on the y-axis? 0.866, just below 1. Okay, because here you go, ready? Here's a great example. Let me go back to the graph. Do you see at 0, what's the y value? 1. Do cosine of 0 in your calculator. That's where it's getting it from. It's going to the graph and saying whatever degree measure you want, we're going to go on the x-axis to that degree measure and find out where its corresponding y value is. And do you see, and here's another quick fact, honors kids, the cosine graph never gets above where on the y-axis? You will never find a degree where you go cosine of that degree, it'll be bigger than 1. Never. Or smaller than -1. The cosine values are always between -1 and 1. All right, you will never be able to find me a degree that gets bigger than 1 or less than 1. Go ahead, Grace. When it is, does it become?
Like how part of the graphs.
Yep, anywhere from 90 to 180. Go ahead, pick an angle between 90 and 180 and do the cosine of it. It's always going to be negative. And actually, let me go 90 to 270. Cosine's always negative. Yep. Anywhere from 90 to 270, cosine's always negative. Sine is always negative from 180 to 360. Okay. And yes, you can have angles bigger than 180, believe it or not, which you'll find out next year. We good there, Letty? Okay. Yes, Sammy, sure. Go ahead.
So for sine and tangent, do they both?
Ooh, tangent, sine and cosine aren't that. Tangent's a whole new ball game. All right, which I won't get into too much, but here you go, just to show you what the tangent curve looks like. Tangent x. That's what the tangent curve looks like. And you see how there's kind of gaps in here? Like the curve never really hits this vertical line. If you guys do tangent of 90 in your calculator, it'll say, sorry, no go. Error, right? There is no value at tangent of 90. That's why there's no, the curve doesn't go over to 90, doesn't go over to 270. Okay, but that's what the tangent curve looks like. Yep. What do you mean? It's
like once it goes like past where you see right there, is it like
it keeps going up, it keeps going up and keeps going down.
so those are just their own line?
Correct. All right. Everybody all right? All good? Go back, everyone all right? It comes up every year, which is fine. I like to have that discussion. And you guys go really in depth with this next year. All right, you do a whole unit on graphing this and finding out angles are bigger than 180. Okay, so going back, next one here. Well, look at that, even better picture. John's at the top of a building watching his friend approach it. His angle is a 40-degree angle of depression now, angle of depression. So he's at the top, just like Zach was standing on the chair, looking down. But here's the thing we have to remember. That is not the angle of depression right here. It's formed with the horizontal line of sight. Like I showed you guys with the string, it is outside the triangle, that angle of depression, 40 degrees. The rooftop, 16 meters from the ground. So here you go. And John's eye level is about 1.8 from the rooftop. Where's the 1.8 going? Next to John here, 1.8 meters. Yep. And you can always assume a building, a flagpole, a tree is always perpendicular with the ground. Nothing's leaning in here, all right? Nothing's leaning. What's his friend's distance from the building? His friend's distance from the building. All right, I need you to help me solve a big problem before we solve this. I cannot use sine, cosine, tangent unless the angle is inside the triangle. And right now we have no angles inside the triangle. Is there any way I can use that 40 degrees, the angle of depression, to get an angle inside the triangle? Mike?
Isn't the horizontal line that that's coming from him, is that perpendicular to the building?
It is perpendicular because horizontal and verticals are perpendicular, so it makes what type of angle? A right angle. So if that's 40, the one next to it, 50. There's one way out. There's another way I'm going to get out of you too. Grace? They're parallel to each other, yes. So that 40, alternate interior angles are congruent, yes. Whoa, let's dig even deeper there. Let's keep going with Grace's thought. Alternate interior angles are congruent. Didn't we just have a name for that angle as his friend looks up to him? So what can you tell me? The angle of depression is always equal to the angle of elevation. All right, those two are always equal to each other. Depression and elevation always equal, yes. Okay, so whatever you prefer. You can put the 50 complementary to the 40 or the 40 down here for the alternate interior. It's up to you. Yes, Zach?
So for the purpose of this problem, are we going to assume that, let's see, what's his name? John is standing directly on the edge of the building?
Yes.
Okay.
Yes. Okay. And we can assume too he's looking down to the feet, so there's not a little gap in here. All right. Good. All right, so I'm going to keep my 40 there just so I don't have to erase anything. So if I keep my 40 there, and again, you guys may use a different ratio if you put the 50 here. All right, I have the adjacent side. You guys have the opposite side if you use the 50. I have opposite right now here. You guys would have adjacent if you use the 50. All right, so either way, though, both of us are going to use what? Tangent of 40, you may use tangent of 50. Tangent of 40, I'm going to do 16 over x. If you did the tangent of 50, you're doing x over 16. Yes?
Shouldn't it be 16 plus 1.8?
Oh, second time today I've done that. You would have thought I learned my lesson from 5th period. Yes, that is correct. The opposite side's not 16. It's the full side here, so 17.8 over x. One job. $21.2 meters. Got it. Some new life terms here for you. If you're in a lighthouse and you're at the top of the lighthouse, you're actually in the gallery of the lighthouse. Yep. A little something more than math. And you spot a ship at an angle of depression 20 degrees. Okay, so you're at the top. You spot the ship at an angle of depression with the horizontal, remember, of 20 degrees. Lighthouse, 28 meters tall. Cliff, 45 meters tall. What's the horizontal distance from the ship to the lighthouse? Horizontal distance. Hey, quickly. I take that word horizontal out and I say, what's the distance from the lighthouse to the ship? I'm now looking for the hypotenuse, okay? If I want the horizontal distance, I will specifically ask for it like I did in this one, okay? All right, you guys want to do alternate interior or complementary? Okay, so 70. Got a little 70 there. So if we're doing that one, we're going to have to use tangent again, and I know it's the third time in a row, but it'll change. Tangent of 70 equals y over, I'm not going to make the same mistake for a third time. Not over 28, not over 45. 73. $200.6 meters. Anything you guys want to ask there? Yes.
Wait, is that the diagram? The thing that
Yeah, I sketched it for you.
wait,
It's the diagram that relates to the problem. What? What's the question? You sure? You didn't have to sketch anything here because the diagram was provided. Unlike the next one where I'm going to be walking around critiquing everybody and your artistic skills. No diagram provided here. Okay, and I'm going to be the first one to go, so I'm joining the crowd. The angle of elevation to an airplane viewed from a control tower. Have you seen a control tower before at the airport? It's the tall building. I don't know. I don't know how to help you. I drew a hammer earlier. Okay, there's your control tower. Don't start. Don't start. I'll be around in a minute. Trust me.
That one looks like the one in Atlanta.
Do you take pictures of different control towers when you go to visit different cities?
No, I just.
Like, hey, I'm not making fun of. Just people have their passion. People collect stamps. People scrapbook. You take pictures of control towers. That's your thing, Zach. That's your thing. Hey, as long as it makes you happy. That's all I care about. All right. Don't worry, I'll be around, everybody. I'll be around in a second commenting. Okay, the angle of elevation. So again, how's elevation formed? From the horizontal, looking at your object, 7 degrees. 7 degrees. A couple other quick points here. 200 feet for the height of your control tower. And now they give us this 5,200 feet, which represents the altitude. That's how high the plane is above the ground. So if we're on the ground looking up, the plane's 5,200 feet above us. All right, so from the ground up here, 5,200 feet. And we are finding, now here's exactly why I just told you that in the last problem. It says how far away is the control tower. If I want the horizontal distance, I'll ask for it. So if I'm asking for the distance from the control tower, I'm actually looking for the hypotenuse here, the direct distance, not the horizontal distance, the direct distance. So I'll give you guys an opportunity right now to see what you think. How can you get a side of the triangle to do sine, cosine, tangent? Some of us, I did not know that UFOs were the top of a control tower. Okay, going with the old hammers. I like it. Good. Okay, let's see it. Let's see if you can find the distance. Got some flashlights. I like it. Not control towers.
Question about this one. Are we just going to assume that the person, it doesn't say that the height of the person is included in that. Are we just going to assume that, or it doesn't say
Yeah, it's from the top of the cliff there, going down. Okay.
Wait, this is that?
Correct. Yep. So you're going to use 40 for your side. Okay.
It's just like the 200 feet, like include the little like thing, or is it just like is it
No,
the
it's
entire?
it's the entire thing. So yeah, it's going to be subtracted from the altitude. All right, what are we deciding on using here? Which ratio? The sine ratio. Why? Because if the altitude's 5,200, the tower's 200, that leaves what for the one leg here? 5,000 feet. And that's opposite. So the sine of 7 should be the opposite 5,000 over the direct distance x. And this is this also a nearest foot on this one. So you'll see it's pretty far away. $41,000. 28 feet. Questions on this masterpiece? And then a little bit, sorry, I got to go a little dry here. Rhombus. Start thinking about your properties other than all four sides are equal. Rhombus. A, B, C, D. Remember how to label a rhombus or any quadrilateral. Never jump diagonally. Clockwise or counterclockwise, but not diagonally. Speaking of a diagonal, one of them's 80. AC is 80. And BAC, that angle you formed with the diagonal, 42 degrees. What's the length of the other diagonal? And it's not 40 because it's not a rectangle. Diagonals are not congruent in a rhombus. So as I draw the next diagonal that I need to find the length of, anybody want to just start yelling out some properties I should be aware of right now? Form right angles and bisect each other. So what just happened to that diagonal of 80? 40 and 40. And you told me that they were perpendicular, form a right angle. Am I going to be able to find BD right now? No. But I can find part of BD. How? Find this portion in this right triangle and do what with it to find the entire diagonal? Multiply it by 2. All right, because diagonals bisect each other, these two are congruent. So once I use sine, cosine, tangent on this right triangle here, I can multiply it by 2 and round. All right. How do I find x? What's going to be the ratio? Tangent, yep. Day 3, I don't have to label much anymore. Tangent of 42 equals, anybody help here? Opposite, x over 40. Will this be the length of BD? No, so keep it right in your calculator. Don't round it yet. Then when you multiply it by 2, sure, go ahead and round it. And nearest integer is nearest whole number. An integer is a positive or negative whole number, but we don't have to worry about the negatives here. And that should end up being 72 when you get to it. And I'm going to let you finish this off right now. How do I find a side? I could do Pythag, or I can do any of the ratios that involve what's y acting as hypotenuse. So cosine, sine, Pythagorean theorem. But if you decide to use this side at all in Pythag or sine cosine, you have to use the non-rounded answer here. The whole thing. All right, if you decide to use that side we just found. All right, so go ahead, take up the couple minutes here we have left. I use cosine. And as you guys are keep finishing here, make sure you end up with 54 for the side of the rhombus. Keep going strong here. Are we getting 54 here? Okay. Block off maybe 15, 20 minutes over break to get the homework done, and you'll be fine.